Okay, so for number 1, we're going to be doing a right-hand Riemann sum, I believe. So we're not going to need to draw the picture. We got our shortcut here. We have our bases are the distances between the x values. So those are the bases of my rectangles. And since we're doing a right Riemann sum, all the numbers on the right side of the y values are my heights. So we're going to multiply height times base, and we should be able to get all of our areas that approximate the integral above. So final answer for that one, 12. Let's go ahead and take a look at another one here. For number 2, we're doing a left-hand Riemann sum. Same thing, these are still the bases. But when you're doing a left-hand Riemann sum, we don't use this one, but all of these ones are the heights, because they're the numbers on the left. And so we have -6, -3, -2, -1, making -12, I guess. All right, next one. I'm going to do a trapezoidal sum for this one. Okay, so for these ones, let's see. The bases here, we're actually going to call these the heights on these ones. So the heights are 1, 1, 1, and 6. These numbers down here are all the bases. So for my first trapezoid, we're going from 0 to 1. So the height is 1. You divide the height by 2, and you're going to multiply it by the sum of the bases, and these are the bases, 4 plus 5. The next trapezoid goes from 1 to 2. That one also has a height of 1, and its bases are 5 and 6. The next trapezoid goes from 2 to 3 with a height of 1, and its bases are 6 and 4. And then finally we have the last trapezoid, which goes from 3 to 9, which is 6, so that's 6 over 2. And its bases are 4 and 2. And now we get to calculate all those and add them up to estimate the area under the curve, which approximates that integral. So this one would be 9 halves, this one would be 11 halves, this one would be 5, and the next one would be 3 times 6, which is 18. Okay, if I add these together, I get 23. If I add these together, I get 20 over 2, which is 10. And adding those together, I get 33 would be my final answer for that one. So that's the trapezoidal sum. Next, we have a midpoint sum. So you want to pay attention to a couple of details here. Notice that we're only going from -2 to 6. So I'm only looking at this much of my table. We aren't using this at all. Okay. I believe the directions also stated something to the effect of, let me see, a certain number of subintervals. See, it says do 4 subintervals. Okay. So if I'm going to do 4 subintervals, let me bring back where I was. We're going to take our last x value, and we're going to subtract from that our first x value, and we're going to divide by 4, which gives us 2. So that tells me what each of my subinterval widths are going to be, or the widths of my rectangle. So my rectangle is going to go in intervals of 2. So I'm going to go from -2 to 0, and then from 0 to 2, 2 to 4, 4 to 6. So all the bases of these midpoint rectangles are going to be the same. We're going to have 4 subintervals, each with a width of 2. Okay. Now, when you're doing a midpoint rectangle, you're going to use the middle height. So if here's my first rectangle, the midpoint, the middle y value is that one. So it's going to be 4 times 2, which is 8. The next one, from 0 to 2, the middle is 5, so -5 times 2 is -10. And then the next one goes from 2 to 4. The middle height there goes to 2, which is 16. And then finally the last one, we're going from 4 to 6 there with a middle height of 7, which gives us 14. So I know that those make 30. Take away 10 is 20. Plus 8 is 28 is our final answer for that one. So you got to pay attention to these intervals here that they're giving you. They may not be asking for the entire table. Be careful with that. The next question asks us to use the same table, but it's a different question. Okay, saying from -2 to 5, find f prime of x. So I'm going to go back. So now notice the difference. For this one, it's f of x. Okay, and we're approximating that using a midpoint sum, and that's the area under the curve. However, for the next question, it's different limits. We're going from -2 to 5, but we're not integrating f of x anymore. We're integrating f prime. Now, we don't have any values for f prime, so you can't do it the way we did this one up here. But what we can do is we could do the fundamental theorem of calculus. The integral of f prime is f, right? And since it's a definite integral, we're going to do the top minus the bottom. And now, by integrating this, we've got f values which are in the table. And now we can just go ahead and plug in the numbers they give us and find it. So it's a different question. It looks very similar, but because this is a derivative instead of the original function, the way you do it is very different. So for the one where the function matches these values, that's a sum using geometry, right? But when it's a derivative, you do the fundamental theorem of calculus. So f of 5 is 7, and f of -2 is also 7, which means 7 minus 7 is 0. So the answer to that one is 0. All right. Next one. We did that. Determine if each scenario below would give an overestimate or underestimate for this function. Okay. So I gave you guys a little chart in class. We talked about how if the function is increasing and decreasing, that will affect whether it's an overestimate and underestimate, but it also depends on whether the sum you're doing is a right-hand Riemann sum or a left. Okay. Now we talked about how when a function is increasing and it's a right-hand Riemann sum, your rectangles go above the curve, and therefore it's an overestimate. Whereas if it's decreasing, your rectangles are under the curve, and therefore that's an underestimate. If you're increasing and you do a left-handed sum, that's also an underestimate. If it's a decreasing function with a left-handed sum, oops, goofed up that one. That's an overestimate. Now, I'm wording the question a little bit differently here. I am telling you it's a right-hand sum, but what does this mean? Well, that means the slope is greater than 0. When the slope is greater than 0, that means it's increasing. So another way of saying your function is increasing is just by saying g prime of x is greater than 0. And therefore, this is just another way of saying that it's decreasing, is if you say that g prime of x is less than 0. Okay, so what we have here then is we've got an increasing sum, a function with a right-hand Riemann sum. That would be an overestimate. Now on the test you have to explain your answer. Your answer would be just basically stating these two things. You would say it's an overestimate because of that and that. So I'll do one official statement, but after that I probably won't write them out because you guys should have the idea after that. But So for part 1, we would say this is an overestimate since g prime of x is greater than 0 on the interval a to b, and we are doing a right-hand Riemann sum. We could just say sum. So there it is. That's in there, and that's in there, and my conclusions in there. Those 3 things should be present in your explanation. Okay? So that's how those go. For the other ones, I won't write it out so officially, but I'll say it at least. All right. Next one. Left-handed sum increasing. That would be an underestimate. The reason is, this is an underestimate because g prime of x is greater than 0, and it's a left-handed sum. Next one, right-hand sum, g prime is less than 0. That means decreasing, and right puts me in this box here, which is an underestimate. So we would say that's an underestimate, the reason being g prime of x is less than 0, and we're doing a right-hand Riemann sum. Last one, left-hand Riemann sum, g prime of x is less than 0. G prime of x is less than 0, left-hand sum gives me an overestimate. And once again, the reasoning would be g prime is less than 0, and it's a left-handed sum. So, we move on to number 7. If f of x is increasing on the interval from x equals a to x equals b, which of the following would not necessarily give a better approximation of the area under the curve than a right-hand Riemann sum with 4 subintervals? Okay, so notice it says not necessarily give a better approximation. So when you have an increasing function and you're doing a right-handed Riemann sum, it's an overestimate, right? If you do a left-handed Riemann sum, it's an underestimate. Okay, so I would say a left-handed Riemann sum does not necessarily give a better approximation, it just gives an under approximation. Now, midpoint and trapezoid sums, we're going to cross this off. Those always give better estimations than left or right-handed sums because they make up for their error. Whether you're doing a midpoint sum or a trapezoid, they always get closer. You know, like trapezoids follow the curve really well. So since they follow the curve, they usually give a pretty nice estimate. They're not like right-hand sums or left-hand sums which go over the curve. You know what I mean? Same thing happens with midpoint sums. When you're doing a midpoint sum, you always get a little above and a little under, so it follows it pretty good. That's not a good example, but let me try to do a different one. So a midpoint would look like this. You always get a little bit over and a little bit under. And therefore that's a better approximation because the over cancels out the under. So both of these we're going to cross off. But a left-handed sum would not necessarily give a better one. Let's take a look at this one. A right-handed sum, so that's the same thing that we have here, but it's got 8 subintervals instead of 4. But we've also talked about how the more rectangles you have, the better the estimate. So this would have to be a better estimate than this one. So that one would necessarily give a better approximation, so we don't want to choose that. This one would definitely not give a better approximation because it has less rectangles, and therefore it would be a worse approximation than the one we have. So the 2 options up here that would not necessarily give a better approximation would be a left-hand Riemann sum or another right-handed Riemann sum with fewer subintervals. But the other 3 that I crossed off, those would have to absolutely give us a better approximation than we had originally. So just some stuff to think about there. All right, the rest of these are all geometry questions. It says estimate the integral using a right-handed Riemann sum of 7 equal subintervals. Now notice I'm going from 0 to 7. So I mean, if you want to make life hard on yourself, you take your last x value, subtract from your first x value, and divide by 7. But you're just going to get 1 because we're making 7 spots, and that's how many spots there are. So basically, my rectangles are all going to be 1 space wide. So I'm going to draw a rectangle here. Wait, what is this asking for? This one's asking for a right-hand Riemann sum. My apologies, let me back up. So first of all, I'm going to go through and put dots at every value of x. X equals 3, 4, 5, and 6. So I want to make sure I've got dots for every x value that we have. We're going by ones. So starting at 0, then 1, then 2, then 3, then 4, then 5, and 6, and so on. So I've got my dots on there. Now I want to draw the rectangles. So if it's a right-handed Riemann sum, we go over. I'm going to do a different color. There's that. There's that. Remember, when you're doing a right-hand Riemann sum, you always start on the right and just draw a little line going straight over. From there, you're going to draw vertical lines that go straight to the x-axis from those points. So now when it's on the x-axis, that's a 0 rectangle, so there's no height to that, so there's nothing there. When you get underneath, straight to the x-axis. Once again, there's nothing there. And so now we get to figure out what are all the areas. So this one's 12. This one's 10. This one looks like it's negative 12. So I'm just going to cancel those out. They're going to be opposites of each other. The next one down here would be 20, negative 20 that is. And the next one would be negative 18. So I have 10, negative 20, and negative 18. So the right-hand Riemann sum with 7 subintervals would give me 28. So what did I do here once again? I went through and I put dots at every x value. And then I drew my little, oops, that one doesn't go there. Then I drew my little lines, drew the rectangles, found the area. Let's do another one here. For number 9, we're doing the same thing, but it's a left-handed Riemann sum. So we still want to put a dot at every value of x. We're going by ones. So 3, 4, 5, 6, 7. And this time we want to do a left-hand Riemann sum, so we're going to start there and go straight over on the left side. Once again, draw a vertical line straight to the x-axis. If the lines are already on the x-axis, that's a 0 height rectangle, so we don't do anything with that. All right, so I've got 12, 10, negative 12, and once again, those are just going to cancel each other out. Negative 20 and negative 18. And interestingly, I think we just got the same answer we did last time. Okay, so it's the same number, so we're still going to end up with negative 28. That doesn't always happen, but in this case it did. All right, next one. Midpoint sum. Now this one we got to pay a little bit attention to the subintervals. When you're doing midpoint sums, they're kind of tricky. First of all, I want you guys to notice we're only going from 0 to 6. All right, so 6 minus 0, and I want to divide this up into 3 equal subintervals, so I'm going by 2's. So I want to put a dot at every 2. So we're going to start at 0, then I'm going to go over 2 and put another dot. Over 2 and put another dot. Over 2 and put my last dot because I stopped at 6. We're going from 0 to 6 only. Okay? So now the next thing that we're going to do is we're going to draw our rectangles. Now when you're doing a midpoint, the base of this rectangle is going to be 2 spaces long. So I'll use pink for my first rectangle there. Now the middle x value there is 1. So I'm going to go up and put a dot where x equals 1. I'm going to draw a hat all the way across, and there's my first midpoint rectangle. My next rectangle is going to go from 2 to 4. Now the middle x value between 2 and 4 is 3. The height at that point is 0, so I have a 0 height rectangle. The next one is going to go from 4 to 6. The middle x value for that is 5, so I'm going to go down on my curve to where x equals 5, and I'm going to draw a rectangle out of that. And there's that one. So for the pink one, we have a base of 2 and a height of 12, which is 24. And for the red one, we have a base of 2 and a height of -20, so that's -40. And so when we put these together, it's going to be 24 take away 40, which is -16. Okay. Okay, next one. This one should have said 7. I'll fix it before I upload it. So now we're going to do trapezoidal sums. 7 equal subintervals. So since we're doing intervals of 7, right? Last minus first over 7 equals 1. We're going by 1. So starting at 0, we're going to put a dot every time we go over 1. And now when you do trapezoids, you start just by connecting every dot to the one adjacent to it. After that, you're going to draw vertical lines from those dots to the x-axis, and you should end up with a series of trapezoids and or triangles. So for this first one here, it's a triangle, and that triangle has a height of 12 and a base of 1. So for the first one, it's a triangle, which is 1/2 the base and height. So 1 times 12 over 2 equals 6. So that first shape has an area of 6. The next shape is a trapezoid. It has a height of 1, and my bases are 10 and 12. So for that one, it's 1 over 2 times 10 plus 12. That's how you find the area of a trapezoid, in case you forgot. It's supposed to be H. And that gives me 13. I'm just going to keep chugging along there. Once again, we have another triangle here. Base of 1, height of 10. That's 5. Next shape, another triangle. Base of 1, height of -12. -6. Next one is a trapezoid. Has a height of 1, and my bases are, it's like 20 and 12. Height of 1, we have -12 and -20 for the bases. That's going to be -16. Next trapezoid, bases are 18 and 20 with a height of 1. They are negative heights though. -19. And the last one there, base of 1, height of 18, and it's a triangle. So we have base times height, which is -18. And then you just add everything all up there. So 6's cancel, right? The rest of this, I think I'm just going to cheat and use a calculator. So here we go. We have 13 plus 5 minus 16 minus 19 minus 9. Getting a total answer of -26 would be the estimate for that. And that'll do it.